The next two pages in your notes, so it's page 38 and 39, are revision from higher. But I thought I just wanted to give you the diagram that should go in here. It's really taking us back to the kind of National 5 style of diagram, where if we use hydrogen, because that's the easiest one, and we have the electron shells of hydrogen, which you now know are the 1s shell, and we've got a positive nuclei in each, and here we have our shared pair of electrons. All we're really asking for in this diagram is for you to show the attraction between the nuclei, or each nuclei, and that shared pair of electrons. So that would be the situation for this pure covalent bond that we learned about. The quick test on page 39 was all higher work, so I'm not really going to go over it very much. I just want to give you the answers to make sure that you are correct. Feel free to get in touch with me if you don't understand any of my answers. So electronegativity is to predict which of these bonds is the most polar. The biggest difference in electronegativity will give you the most polar. So if we look those up, we can see that there's a difference of 0.6 here. There is no difference between the nitrogen and the chlorine. There's only a difference of 0.2 between bromine and chlorine, and there's a difference of 0.2 between nitrogen and bromine. So the most polar is A. Which of these molecules is polar? Methane's totally symmetrical, so that's definitely not polar. Bromine can't possibly be polar because there is no difference in electronegativity. Carbon dioxide is totally symmetrical, so that leaves you with B for a asymmetric molecule and also a difference in electronegativity. Classify each of the following as polar or non-polar. This is polar. Is there a difference in electronegativity? Non-polar, polar, non-polar, non-polar for the carbon dioxide, non-polar for the carbon tetrabromide, non-polar for the chlorine, and polar for that last molecule. Remember that even if a compound has polar bonds, if you have a completely symmetrical tetrahedral arrangement, sorry, that should have been a different bond shown, then regardless what's on these, if they are all the same element, then by default, whether each bond is polar or not, the whole molecule will be non-polar.